Empirical formula is the simplest formula because it's the lowest ratio. Molecular formulas are the true formulas. To solve for empirical formula, you need to take several steps. If you memorize the poem below, it will guide you. Percent to mass, mass to moles, divide by small, multiply till whole. So let's look at our first example. We have 58.87% sodium, 41.13% sulfur. First line of the poem says percent to mass. So all we're going to do is change the percent sign into grams. And when we do that, we are converting the percent to mass. So we have 58.87 grams of sodium, and we also have 41.13 grams of sulfur. The second line in the poem says mass to moles. To convert mass to moles, we are going to use molar mass. So we're going to do dimensional analysis. Remember, diagonals have to be the same. So grams Na, this is equal to 1 mole of Na. We find the mass of sodium off the periodic table. It is approximately 22.99. We'll repeat the procedure for sulfur. So again, diagonals, grams of sulfur, 1 mole of sulfur off the periodic table is 32.06. Now we're going to calculate for sodium by multiplying 58.87 times 1 divided by 22.99. 2.5607 moles of sodium. We're going to repeat for sulfur, 41.13 times 1 divided by 32.06. You get 1.2825 moles of sulfur. When we do calculations, we do no sig figs for empirical formula. You always want to carry 2 to 3 digits after the decimal. If you round too early, your final answer will look funky. So far, we converted percent to mass by making our percent signs into grams, right here. And then we converted our grams to moles using molar mass. Now what we're going to do is we're going to divide by the smallest number. So we look at the number of moles. So we have 2.5607 moles of sodium, 1.2825 moles of sulfur. The smallest number is 1.2825 moles of sulfur. So we're going to divide both numbers by that. So that's 2.5607 divided by 1.2825. And we're going to do the same thing for the sulfur. And so for the sulfur, since we are dividing by itself, we know is exactly 1. The sodium, if I divide this, we should get approximately 1.9966. Again, we do not want to round here. So now we divide it by small. Our last step is we multiply till whole. Here, we're not going to multiply till whole because 1.99 is approximately 2. If we had something like 2.3 or 2.4, 2.5 to 2.8, we will multiply until it's a whole number. We'll round up to 2, so this tells you that in the empirical formula, there are 2 sodiums and then 1 sulfur. So the empirical formula is Na2S. Pause the video, solve this problem on your own, and then check your answer. So again, percent to mass. Since it's given to you in percentages, we're going to change the percent sign into grams. So now we're going to have 10.89 grams of magnesium, 31.77 grams of chlorine, and 57.34 grams of oxygen. Mass to moles. So we're going to use molar mass and we're going to do dimensional analysis. Grams of magnesium, diagonal units must cancel out. This is equal to 1 mole of magnesium. We find its mass on the periodic table. It is 24.30. So we multiply 10.89 times 1 divided by 24.30. Get approximately 0.4481 moles of magnesium. We're going to repeat the procedure for chlorine. So grams of chlorine, diagonals have to cancel out. 1 mole of chlorine is equal to 35.45 grams of chlorine off the periodic table. The grams of chlorine cancel out, so 31.77 times 1 divided by 35.45 gives you approximately 0.8962 moles. And for oxygen, grams of oxygen, 1 mole of oxygen is equal to 16.00 grams of oxygen off the periodic table. This will give you approximately 3.5838 moles. So our next step in the poem, we divide by the smallest number. The smallest number here is by magnesium. So we're going to divide each of these by 0.4481 divided by 0.4481. So for magnesium, it's exactly 1. For chlorine, it's 0.8962 divided by the smallest, which is 0.4481. And when I do that, it becomes exactly 2. For oxygen, we're going to do 3.5838 divided by 0.4481. This becomes 7.997. Remember, we want to always carry 2 to 3 digits after the decimal. If you round too much, your answers come out funky. We do not round until the end. Our last line is multiply till whole. Here we don't have to because this is exactly 1. This is exactly 2. And then here, 7.997, I could round that to 8. So for this particular formula, it is 1 magnesium, 2 chlorines, and 8 oxygen. And 8 oxygen, this is actually magnesium perchlorate. So pause the video, solve this problem, and then check your answer. Here we have the analysis of a sample. It contains calcium and bromine, and it tells you that 4 grams of the 100 grams is calcium. That means the rest must be bromine. So to find the mass of bromine, we take the total mass minus the mass of calcium. So this becomes 100 grams minus 4.00 grams. The mass of bromine is 96.00 grams. Since this is already in grams, I don't need to convert the percent into mass. So we're going to start with 4 grams of calcium. I'm going to start with 96 grams of bromine. So we're going to convert mass to moles using molar mass, dimensional analysis, grams of calcium, 1 mole of calcium. Off the periodic table, it's approximately 40.08 grams. So 4 times 1 divided by 40 is 0.0998. We're going to do the same thing for bromine. So if I do that, grams of bromine, 1 mole of bromine. Molar mass of bromine is 79.90. So this is going to equal to 1.2015. Now we're going to divide by small. So the smallest number here is from the calcium. So we're going to divide each one by 0.0098. So for calcium, this is exactly 1. We're going to do the same thing for the bromine. We're going to divide by the smallest number, 0.0098. This becomes 12.039. So again, we don't have to do the last line because 1 rounds to 1 and 12.039 rounds close to 12. This is approximately 12. The formula is calcium. There's 1 of them. and there are 12 bromines. Just like the previous problem and this problem, for empirical and molecular formulas, we never use diatomics. We only use elements. Pause the video and try this problem on your own, and then check your answer. Just like the previous problem, this is already in grams, so we do not have to do the first line where it says convert percent to mass. So we're going to start with 81.82 grams of carbon, and I'm going to start with 18.18 grams of hydrogen. I'm going to convert my mass to moles using molar mass. Grams of carbon, this is grams of carbon. 1 mole of carbon is 12.01 off the periodic table. So 81.82 times 1 divided by 12.01 is 6.8127 moles. So I'm going to do the same thing for hydrogen. So grams of hydrogen. 1 mole of hydrogen is equal to 1.01 off the periodic table. The grams cancel out, and this is 18 moles of hydrogen. Next, we're going to divide by the smallest number. The smallest number is 6.8127. So I'm going to divide the first one by itself because it's the smallest number. This is going to equal exactly to 1. Second one, I'm going to do 18 divided by 6.8127. This becomes 2.642. So here, I can't just round. The first one rounds to 1, but the second one is 2.6. So I can't just round that to a 3 or 2. So what I need to do is the last line, which is multiply till whole. So we're going to multiply till whole. So I'm going to multiply by 2. 1 times 2 is 2 for the carbon. If I multiply by 2 for the carbon, I need to do the same thing for hydrogen. The hydrogen by 2, and I get 5.284. This number is very difficult to round to a whole number. So 2 is not the correct factor that I need to multiply. So I'm going to try the next one, which is 3. So if I multiply by 3, so 1 times 3 is 3. The second one, if I multiply by 3, so the second one, I'm going to multiply by 3 because in math, if I do 1, I have to repeat the same procedure for everything. 7.926. So here I could round. This is very close to 8. So my empirical formula is C3H8. So pause the video, solve this problem, and then check your answer. So here too, we have percent of nitrogen, and then we have a percentage of oxygen. So the first thing we're going to do is convert the percents to mass by changing the percent sign to gram. So I'm going to have 36.84 grams of nitrogen, and I'm going to have 63.16 grams of oxygen. Now I'm going to go from mass to moles doing molar mass. So if this is grams of nitrogen, diagonals have to cancel out, so that's grams of nitrogen, which is equal to 1 mole of nitrogen. Off the periodic table, the mass of nitrogen is 14.1. So 36.84 times 1 divided by 14.01 is 2.629 moles. I'm going to repeat the procedure for oxygen. Grams of oxygen, 1 mole of oxygen is 16.00 grams off the periodic table. 63.16 times 1 divided by 16 is 3.9475 moles. Now I'm going to divide by the smallest number. The smallest number here is 2.629. So if I do that, the top one for nitrogen becomes exactly 1. The bottom one, 3.475 divided by 2.629 is going to give you 1.501. I can't round the bottom one, so I need to multiply till whole. So I'm going to multiply the top one by 2. So if I multiply the top one by 2, it becomes 2. The bottom one, if I multiply it by 2, it's going to be 3.002, which is roundable to 3. So my empirical formula is N2O3. So molecular formula is the true formula. You do the same procedure and solve for the empirical formula. Once you know the empirical formula, you need to do the ratio of the molecular formula mass to the empirical formula mass. After you find the ratio, it is going to be the ratio times the empirical formula. And that will give you the true formula or the molecular formula. To find the molecular formulas, we need to first find the empirical formula using the poem as before. So pause the video, solve the empirical formula, and then check your answers. Since the percent is given, we have to convert my percent to mass by changing my percent to grams. We have 65.45 grams of carbon. We have 5.45 grams of hydrogen. And we have 29.10 grams of oxygen. Now we're going to go from mass to moles using molar mass. So we use dimensional analysis, grams of carbon, diagonals have to cancel out. There's 12.01 grams of carbon from the periodic table that's equal to 1 mole of carbon. We multiply 65.45 times 1 divided by 12.01, which is 5.45 moles of carbon. Remember, when we do empirical formulas, we always carry 2 to 3 digits after the decimal. For hydrogen, diagonals again cancel out grams of hydrogen. There's 1.01 grams of hydrogen for 1 mole of hydrogen. 5.45 times 1 divided by 1.01 is 5.40 moles of hydrogen. For oxygen, diagonals, grams of oxygen needs to cancel out. There is 16 grams of oxygen for 1 mole of oxygen. 29.10 times 1 divided by 16 is 1.82 moles of oxygen. Next, we need to divide by the smallest number. The smallest number is oxygen. So 5.45 divided by 1.82 is equal to approximately 2.99, no rounding. 5.40 of hydrogen divided by 1.82, this is equal to approximately 2.97. Oxygen is 1.82 divided by itself, so this is equal to 1. We don't have to do the last line because we could round these numbers because they're close to the whole number. So the top number, 2.99, rounds to 3. 2.97 rounds to 3. And this one's the whole number, so it's 1. So the empirical formula for this compound is C3H3, 1 oxygen. Now we need to find the molecular formula. Since empirical formula is the lowest ratio, we need to find the ratio between the molecular formula over the empirical formula. So we need to have the molecular mass divided by the empirical formula mass. The molecular mass is provided in the problem as 110 grams per mole. So we need to find the empirical mass using the periodic table. There are 3 carbons, so 3 times 12.01 grams of carbon plus 3 times 1.01 grams of hydrogen plus 16.00 grams of oxygen because there's only 1 oxygen. The math adds up to 55.06 grams per mole. So the empirical formula mass is 55.06 grams per mole. If I divide this out, this is approximately 1.997. So I could round this to 2. when you do the ratio from molecular to empirical, it will always be close to a whole number. So if you are really off, that means you calculated something wrong. Molecular formula is twice my empirical formula. So it's going to be C6 because it's 3 times 2, 3 times 2, 1 times 2. So it's C6H6O2. My molecular mass is twice the mass of my empirical formula. Pause the video, solve the empirical and molecular formula, then check your answer. Since percents are given, we're going to convert the percent to mass by changing the percent signs to gram. So it's 40.0 grams of carbon, 6.7 grams of hydrogen, and 53.5 grams of oxygen. Now we need to convert mass to moles using molar mass. So we're going to do dimensional analysis. Grams of carbon. 1 mole of carbon is equal to 12.01 grams of carbon. 40 times 1 divided by 12 is 3.33 moles of carbon. For hydrogen, grams of hydrogen, diagonals have to cancel out. There are 1.01 grams of hydrogen to 1 mole of hydrogen off the periodic table. 6.7 times 1 divided by 1.01 gives you 6.63 moles of hydrogen. For oxygen, diagonals have to cancel out too, so grams of oxygen, 16 grams off the periodic table, 1 mole of oxygen. 53.5 times 1 divided by 16 is 3.34 moles of oxygen. Next, we need to divide by small. The smallest number is carbon. So 3.33 divided by 3.33 is equal to 1. For hydrogen is 6.63 divided by 3.33, which is approximately 1.99. Again, we do not round. For oxygen is 3.34 divided by 3.33. This is equal to 1.00. So again here, we do not need to multiply to a whole because the numbers are close to a whole number. For carbon, there's 1. For hydrogen, there is 2. For oxygen, there is 1. So my empirical formula is CH2O. Now to find the molecular formula, we do the molecular formula mass divided by empirical mass. The molecular formula mass is given to you as 180 grams per mole. So we need to calculate the empirical formula mass. There is 1 carbon, which weighs 12.01 grams off the periodic table, plus 2 times 1.01, because there's 2 hydrogens in the empirical formula, plus 16.00 grams of oxygen. Adding these numbers up, you should get 30.03 grams per mole for the empirical formula. So down here we put 30.03 grams per mole. I divide this up. This is approximately 5.99. If your number is not close to a whole number, you made a math error along the way. So that means my molecular formula is going to be 6 times my empirical formula. So if this is my empirical formula, I need to multiply each of the elements by 6. So there's 6 carbons, 12 hydrogen, and 6 oxygens. Pause the video, solve for the empirical and molecular formula, then check your answer. Here again, percent is given, so percent to mass, we change the percent sign to gram. 7.79 grams of carbon. We have 92.21 grams of chlorine. Now we're going to go from mass to mole using molar mass. So using dimensional analysis, grams of carbon, there is 12.01 grams of carbon to 1 mole of carbon off the periodic table. 7.79 times 1 divided by 12.01 equals to 0.649 moles of carbon. Chlorine, grams of chlorine has to cancel out with grams of chlorine. 1 mole of chlorine off the periodic table weighs 35.45 grams. 92.21 times 1 divided by 35.45 equals to 2.601 moles of chlorine. Now we divide by the smallest number. The smallest number is carbon, so 0.649 divided by itself is going to equal to 1. For chlorine, it's going to be 2.601 divided by 0.649. This is going to equal to about 4. So again, we do not have to multiply till whole. We have 1 carbon and 4 chlorine. So my empirical formula is CCl4. Now to find the molecular formula, we do the molecular mass divided by the empirical mass. The molecular mass is given as 154 grams per mole. To find CCl4 molar mass, there is 1 carbon, which is 12.01 grams off the periodic table, plus there's 4 chlorines, so 4 times 35.45 grams of chlorine. This equals to 153.81 grams per mole. This is the mass of the empirical formula. So molecular formula was 154 grams per mole divided by 153.81 grams per mole. The ratio is approximately 1. So that means our empirical and our molecular are exactly the same. They are both CCl4. So molecular formula is no different from empirical formula. Follow the poem, solve for the empirical formula. Do not round. Carry 2 to 3 digits after. Do not round until the end. To find the molecular formula, do the ratio of the molecular formula mass to the empirical formula mass. If your answer is not close to a whole number, that means you made a math error along the way. So resolve the problem.